Yes, we have this question right here. It's asking prove V is a subspace of R3. Let's see how we can do this. So first of all, in this kind of question, we have to check three things. The first thing is it has to contain, if something is in subspace of Rn, it has to contain three things. The first thing is it has to have zero element. The second thing is it should be closed under it's called closed under addition. It should be closed under addition. Also, it should be closed under scalar multiplication. So this should be closed under scalar multiplication. So these are the three things we have to consider before we solve this problem. So let's begin with the first one. They are asking it should be uh, it should contain a zero element. So let's see what we can do. So in order to contain check whether it is containing a zero element, first we have to put 0 for each value x1, x2, x3 and see. So if I put 0 for each of these things, it's going to be 0 equal to 0 plus 0. So if I take this value, then this is going to be 0, 0, 0. Therefore this is belongs to V. Therefore it contains 0, 0 belongs to V. Therefore it contains a zero element. Therefore first one is done. Then the second one is we have to prove it is closed under addition. So in order to do that, let's take subspace xy belongs to V. Then if I take x has x1, x2, x3. So I have to prove this is closed under addition. In order to do that, I have to take random three variables. Like for example, I take y. If I take y, I have to take y1, y2, y3. Then we know this all of them are real numbers. So x1, x2, x3, y1, y2, y3 belongs to R. Then and also we have the information. This is x3 is equal to x1 plus x3. X3 is equal to x1 plus x2. X3 is equal to x1 plus x2. What actually this meaning is, whatever the third number should be addition of the second two number. That's what this is representing. Therefore we can say from this one y, so y3 should be third number should be equal to addition of these two, y1 and y2. So y3 should be equal to y1 plus y2. Then we are going down here, and let's add x and y, see what happens. If I add x and y, this will become x1 plus y1, x2 plus y2, x3 plus y3. So in this case we have three numbers. So according to this, the third number should be addition of first two numbers. So x3 plus y3 should be equal to these two addition of these two, but we have to prove that. Let's see how we can prove this. So first of all, x3 plus y3, I take x3 plus y3, and from the equation we formed already, we created an equation based on this information, x1 x2 and y3 is equal to y1 plus y2. So I put that value. So x3 plus y3 is equal to x1 plus x2, then addition y1 plus y2, and you can say this is commutative. So I can write it as x1 plus y1 and plus x2 plus y2. So if you see, this is equal to this one, x3. If you take x3 plus y3, x1 plus y1, x2 plus y2. So we can say this is closed under addition. So we have proved that is closed under addition. Also we x plus y belongs to V. Then we have to prove this closed under scalar multiplication. So in order to do that, I have take any x belongs to V, then and alpha, I take the random scalar number, alpha is a real number, then x, we have x is equal to x1, x2, x3. Also we know x1, x2, x3 are real numbers. Also we have the information that x3 is equal to x1 plus x2. So first of all, what I'm going to do is I have to, since I take, we have this x value here, I just simply multiply this one by this scalar thing I have to take in here. So let's say alpha x. So if I take alpha x, I have to multiply alpha by everything. So alpha x1, alpha x2, alpha x3. So since we have these three numbers, we have to prove that alpha x3 should be equal to first two addition of first two number. That's the basic thing, right? Since the third value should be equal to addition of first two values. That's the proof we have to prove. So in order to do that, I take this equation alpha x3 and I multiply this one by this equation by alpha. This is going to be alpha x1 plus alpha x2. If I expand this one, it's alpha x1 plus alpha x2. This is proved as alpha x3 is equal to alpha x1 x2. So this is same as this one. So I have proved this is closed under scalar multiplication. So that's all we have to prove. Therefore we can say V is a subspace of R3. So that's all we have to do. I hope you guys like this video. See you next time.